All right, 6-1 polynomials. There's a lot of stuff in here, it's just not very difficult. All right, so bear with me. There are a lot of things to do, but nothing overly difficult. All right, we're going to be able to identify, evaluate, add, and subtract polynomials, and then we're also going to be able to classify and graph polynomials. Okay, so example 1, identifying the degree of a monomial. All right, so doing your vocab, you know what a monomial is. All right, so I'm going to give you the steps first. Identify the value of each exponent, and then add the value of each exponent. So identify the degree of each of these monomials. Z to the 6th. Okay, identify the value of the exponent. The exponent is 6. Okay, add the value of each exponent. There's only one, so the degree is 6. B, 5.6. There is no variable, so there is no exponent, so that's a 0, so the degree is 0. C, you have x, so its exponent is 1, and you have y, its exponent is 3. You add 3 and 1, you get 4, so that is the degree of 4. And then D, you have a squared, so that's 2, B, that's 1, and C cubed, that's 3. So 2 plus 1 plus 3 is 6, so this also has a degree of 6. Like I said, not overly difficult. There's 2 for you to try. All right, classifying polynomials by degree. All right, so polynomials, it tells you constant is so there's no exponent, linear if there's just an x, quadratic if it's the highest is squared, cubic if it's cubed, quartic if it's to the 4th, and quintic if it's to the 5th power. All right, so you can use that list to name things. So classifying polynomials, step 1, rewrite it in standard form. Step 2, identify the leading coefficient, so the number out front. Step 3, identify the degree. Step 4, identify the number of terms. And then the last step is just naming it. Alright, so 3 minus 5x squared plus 4x, rewrite it in standard form. Alright, so the largest terms first, so negative 5x squared plus 4x plus 3. Identify the leading coefficient, so the value in front of the variable, so the one all the way out in the front. So the value in front of the x squared is negative 5. Identify the degree. So what's the highest exponent in this polynomial? It's a 2, so its degree is 2. Identify the number of terms. So how many terms are separated between plus and minus signs? So you have the negative 5x squared, the 4x, and the 3, so there's 3 terms. All right, then we're going to name it. It has a degree of 2, so it makes it quadratic, and it has 3 terms, so it's a trinomial. So this is a quadratic trinomial. Let's look at another one. Negative 18x squared plus x cubed minus 5 plus 2x. Rewrite it in standard form, highest exponent to lowest exponent. So you get x cubed minus 18x squared plus 2x minus 5. Identify the leading coefficient. So what value is out in front? Well, that's a 1. Identify its degree. What's the largest exponent? That's a 3. Identify the number of terms. How many are separated between plus and minus signs? So you have x cubed, negative 18x squared, 2x, and negative 5. So that's 4 terms. Okay? So the degree is 3. So that makes it cubic. It has 4 terms. So it's a polynomial with 4 terms. So this is a cubic polynomial with 4 terms. Use a chart if you need a name for quartic, quintic, stuff like that. All right, so classify yours. Enter that in online. All right, third example, adding and subtracting polynomials. Okay, so rewrite it in standard form. Align all your like terms, and then add or subtract depending on what it calls for. Okay, so add or subtract, write your answer in standard form. So we want to take 2x cubed plus 9 minus x and add it to 5x squared plus 4 plus 7x plus x cubed. All right, so we're going to rewrite it in standard form. So I get 2x cubed minus x plus 9 plus x cubed plus 5x squared plus 7x plus 4. Now we want to align all the like terms, okay? So you notice for the top one, my 2x squared or my 2x cubed polynomial, I did not have an x squared term, so I'm going to leave it blank, or if you want to fill in a 0 there, you can. All right, I need everything to align. Now, since it's adding, I'm going to add them together. All right, I'm going to take my terms that are similar, so 2x cubed plus x cubed is 3x cubed. Then I have 0 plus 5x squared is 5x squared. Negative x plus 7x is 6x. And 9 plus 4 is 13. Okay, so now we just added two polynomials. All right, the process is exactly the same for subtraction. It's just now you're subtracting. So let's look at one. I have negative 36x squared plus 6x minus 11 minus the quantity of 6x squared plus 16x cubed minus 5. Rewrite everything in standard form. So the first one's already in standard form. The second one, remember this should be minus here. Minus. Should be 16x cubed plus 6x squared minus 5. Align all my like terms, leave gaps where I don't have values. All right, so my first one, I don't have an x cubed, but I do in my second polynomial. And then in my second polynomial, I don't have an x term like I do in the first one. So I'm leaving blanks here and here to account for that. All right, now it's subtraction. 0 minus 16x cubed is negative 16x cubed. Negative 36x squared minus 6x squared is negative 42x squared. All right, so negative minus a positive is, negative 42. 6x minus 0 is 6x. And negative 11 minus negative 5, so same as negative 11 plus 5 is negative 6. Make sure you take your time when you're subtracting. Make sure you're doing the proper mathematical operations when you're subtracting negatives or subtracting positives. All right, there's yours to do. This one is subtraction, so make sure you take note of that sign. Okay, now we're going to look at an application. Okay, cardiac output is the amount of blood pumped through the heart. The output is measured by a technique called dye dilution. For a patient, the dye dilution can be modeled by the function f of t equals 0.000468 x to the fourth minus 0.016 x cubed plus 0.095 x squared plus 0.086 x. T represents time in seconds after the injection, and f of t represents the concentration of dye in milligrams per liter. Evaluate f of t for when t equals 4 and t equals x, or t equals 17. Describe what the values of the function represent. So all we're doing is plugging in 4 and 17 into the function. Okay, so you plug in 4, you substitute it in, use a calculator, do the math, you get 3.8398. Also, substitute in 17. It's the exact same way. Type it into the calculator, do the math, you get 1.6368. Okay. F of 4 represents the concentration of dye after 4 seconds. F of 17 represents the concentration of dye after 17 seconds. All right. Don't freak out about it being a word adventure. Okay. All you're doing is substituting in the values, doing the math, and explaining what those answers represent. Okay. The last thing that we're talking about for this section, like I said, there is a lot of stuff that we're covering, but nothing's overly difficult. All right. The last thing is, oh, this is your now you try. Oh, let me forget. So you're just substituting in these values of the equation and describing what the values represent. All right, the last example, last thing we're doing. Graph each polynomial function on the calculator. So use the online calculator that I have if you don't have a graphing calculator, and then describe the graph and identify the number of real zeros. All right, so 2x cubed minus 3x, when you graph it, looks like this. Okay, describe the graph. So from left to right, the graph increases, then decreases, then increases again. Okay, you can see that just by looking at it. Increase, decrease, increase. And then it says identify the number of real zeros. Look at where across the x-axis. 1 here, and 1 here. So that makes 3. So that's all you have to write. Increase, decrease, increase from left to right. 3 real zeros. So one more. Negative 1/6 x to the fourth plus 2x cubed minus 2. I graph it. It looks like this. From left to right, it increases, then decreases, then increases, and finishes off by decreasing. Crosses the x-axis here, 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 and here. So I have 4 real zeros with an increase, decrease, increase, decrease. Okay? So this one's yours. Last one, describe it. Give the number of real zeros. You are done. I'll see you tomorrow.